YouTube script -500 words -2:30-minute. What if the AI assistant you trust with your email, your calendar, and your memory could be turned against you by a single email? Not by tricking it into reading something dangerous, but by making it store a false memory that comes back to bite you days later. That's not a sci-fi hypothetical. It's what researchers demonstrated this week, and it's part of a much bigger story. AI agent security is facing its watershed moment. Welcome back to the Frontier AI Research Digest. This week's papers dropped a cluster of results that together paint an alarming picture. As AI agents become persistent, they remember you, they browse the web for you, they execute code for you, attackers are finding entirely new ways to compromise them. And the defenses? They're scrambling to catch up. Let's start with the most chilling result. A new paper called When Claudes Remember But Do Not Tell introduces what the authors call Stealthy Memory Injection. The idea is simple: an attacker sends you a single email. Your AI assistant reads it, and somewhere in the email is hidden content that tells the agent to write a piece of false information into its long-term memory. The agent responds to you normally, no red flags. But days later, when you ask it about your travel plans or your schedule, the poisoned memory surfaces and the agent acts on attacker-controlled data. The researchers built a benchmark called WhisperBench with 108 attack scenarios, and their attack framework, MemGhost, achieved an 87% success rate against production agents. This isn't theoretical, it works across different agent architectures and memory backends. Then there's agent data injection attacks, or ADI. This is a new category of attack that's distinct from the prompt injection we've all heard about. Instead of tricking the agent with malicious instructions, ADI attacks disguise malicious data as trusted data, things like resource identifiers or tool call responses. The agent doesn't think it's being attacked, it thinks it's just processing normal data. But the result is the same: the agent takes unintended actions. The researchers found critical vulnerabilities in real-world agents including Claude Code, Codex, and Gemini CLI, leading to arbitrary click attacks on web agents and remote code execution on coding agents. But it's not all bad news. A paper from ETH Zurich and Google DeepMind introduces untrusted content masking, a defense that restores the trust boundary by redacting untrusted regions of web pages before they reach the agent's perception. The key insight is that the DOM structure of a web page tells you what's trusted and what isn't, without even reading the content. It's elegant, and it provides provable security guarantees. Here's what ties these papers together. The AI industry is rushing to deploy persistent agents with memory, with tool access, with the ability to act autonomously. But the security model for these systems is still catching up. We're discovering that the same persistence that makes agents useful also makes them vulnerable in ways that traditional software security didn't anticipate. The message from this week's research is clear: agent security can't be an afterthought. We need architectural guarantees, data isolation, trusted execution boundaries, verifiable memory, not just better prompts.